This is section 4.1, and we're now officially beginning chapter 4. And chapter 4 is about using equations to draw lines and graphing lines and stuff like that. So 4.1 is about using equations to model patterns. Okay, so for example, you're going to be given some scenarios, and you're going to need to be able to find an equation that represents that scenario. Okay, so we're going to start off with matching question. Okay, so what's going on here is when you look on the left, you have a bunch of scenarios. Okay, like the first one is Jim works at IGA, he makes $15 an hour. And what I want you to do is, from the right side over here, there are a bunch of equations. Which one of them is for finding how much he makes, which is his salary? Okay, that's the first one. Number two is, hey, you go buy apples. Apples cost $1.25 each. How much does it cost to buy a bunch of apples? Okay, so which one of these formulas is the equation for the cost to buy, a bunch of apples? Okay. And the third scenario is one car can fit 5 people, and how many cars can you fit with several cars? Okay, so the formula you want is, the number of people you can fit in, if you're given a number of cars. Okay. So what I want you to do right now is, can you pause the slide and see if you can match which one of these formulas on the right corresponds with the scenarios on the left? Okay, so I'll pause right here, and then when you're ready, just continue. All right, suppose you've already tried this question. So the first one is, what's the salary? Is it going to be $15 dollars per hour plus the number of hours worked, or is it going to be multiply or minus? And so, for example, if you work 1 hour, you make 15. You work 2 hours, you make 30, and that's your salary, right? You work 3 hours, that's 45. So the answer would be B. Okay, your salary is the number of hours you work times 15 for each hour. Okay. And then number two, it's almost the same thing. You're buying apples, and each apple is $1.25. So will it be times, plus, or plus? So these two are actually the same. So just cross E off. And for this one, the answer is D. Okay, so number of apples times 1.25 will give you total cost. The last one is, hey, one car can fit 5 people. How many cars can you fit with several cars? So number of people. Is it 5 plus number of cars, or 5 times number of cars, or 5 divided by number of cars? The answer will be G again. And in the normal VC pattern, they're all multiplying, right? So if you have number of cars, let's say 1 car can fit 5 people, 2 cars would then be 10, 3 cars would then be 15, right? So number of cars, you times it by 5, you get the number of people you can fit in. Okay, so answer is G. So this is just an example of how you can use these formulas to represent each of those scenarios. Okay. So writing equations. Okay, so you can use equations to model situations in the real world. As you get older, if you ever go into like sciences and so on, you realize that you can actually use equations to solve very complex problems. Okay, and having equations makes complex problems a lot easier. Okay, and the first step is to always define a pattern. Okay, and so right now in grade 9, we'll look at a couple scenarios, and I want you to see if you can find the pattern. Okay, so here we go. First one is you're going to be given a bunch of diagrams. Okay, so the following diagram shows number of triangles created with number of toothpicks. Okay, so here's the first diagram. Okay, and you actually need 3 toothpicks to make this. Okay, so one triangle requires 3 toothpicks, and then you want to make the second diagram. You have 2 triangles, but you need 5 toothpicks. Okay, and here's the third diagram. You have 3 triangles, and you need 7. So what I want you to do is, write an equation to describe how many triangles, which is T, versus the number of toothpicks that you needed, okay? So the first one was 3. This was like 1, 2, 3, 4, 5. This is like 1, 2, 3, 4, 5, 6, 7. Okay, so first step is, make a table of values. So 1 triangle, 3 toothpicks. 2 triangles, 5 toothpicks. 7 would be, 3 triangles would be 7. And then 4 will be, if you look at the math, you plus 2, you plus 2. Next one's also going to be plus 2, so you get 9 and 11. Okay, and the formula for this is actually the number of toothpicks needed is 2 times the number of triangles plus 1. And what I'm going to do later on is show you how to find this formula really easily when you're given this table of values. Okay, so here's your first example. So number of toothpicks used is equal to number of triangles times 2 plus 1. Okay, practice. Okay, so here's one, and I want you to do the same thing. So the scenario behind it is your garden is 1 by 1, so this is like 1 meter by 1 meter, and you actually need 1, 2, 3, 4, 5, 6, 7, 8 tiles to surround it. Okay, so this is like size 1, and you need 1, 2, 3, 4, 5, 6, 7, 8, 8 tiles. Okay, this next one is size 2, and you need it like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tiles. So size 2, 10 tiles. Okay, this is size 3. Okay, and the number of tiles will then be 12 tiles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So size 3 will be 12 tiles. So what you want to do now is, fill in this table of values. So S is the size of the garden, and T is the number of tiles. So you get like 1 gives you 8 tiles, size 2 gives you 10, size 3 gives you 12, and then size 4 will be, and if you look at the math, you plus 2, you plus 2, next will be plus 2, 14, and 16. Okay. So you can pause here for like, 1 second if you want, and, see if you can find the formula. So I'll pause it right now. And so if you had some time to look at this question and see if you can find the formula. And the formula actually is your number of tiles, so T, number of tiles, is equal to the size of the garden times 2, and then you plus 6. Alright? One way to visualize this is, just think of as, okay, this is size 2, right? And then you multiply by 2, this way you cover this one, you cover this one, you cover that, right? So whatever the size is, when you times 2, it takes care of the ones that are on top and below the garden. And then you add 6 because you have 1, 2, 3, 4, 5, 6, like that. Okay. Again, size 3 takes care of these ones, and you multiply by 2. And then you add 6 because of this one, this one, this one, this one, this one, that one. Alright, that's one way to look at it. Alright, so number of tiles used is equal to the size of the garden times 2, and then plus 6. Okay, so finding patterns. Okay, so this slide here explains to you, let's say when you're given table values, how do you find the pattern? So this is actually the most important slide of this lesson. Okay, so try to put a star on this slide if you can. Okay, so right now, this question is, here's T and here's P. T is the number of tiles, and T is the number of triangles, and P is the number of toothpicks you needed. And so if you have 1 triangle, you need 3 toothpicks, 2 triangles, you need 5, 3, you're given 7. So how do you find this pattern? Let's say if it doesn't come naturally to you. Okay, so this is what I would do. Okay, so you look at the columns, and you want to see which one's increasing faster. Okay, so you look at the left column, or on the right column, you see how these ones are increasing by 2? Like from 3 to 5, you go by 2. 5 to 7, you also go by 2. 7 to 9, and 9 to 11, they're all going up by 2. Okay? And when you look at the left side, they're all going up only by 1. So if I ask you, hey, which side is increasing faster, the answer would be the P side. This side is increasing faster. And the thing is, you don't want one column to be increasing faster than the other. You want them to be increasing by the same value, right? So because these sides are, the right side is faster by 2 times faster. So what I'm going to do now is I'm going to take this left column, I'm going to multiply everything by 2. Okay, and then see what happens. Okay, so here we go. I'm going to multiply the left side by 2. So that means the 1 becomes a 2. So instead of T, now it becomes 2T. 2 becomes a 4, 3 becomes a 6, 4 becomes an 8, and 5 becomes a 10. So now you compare like the rows, like go from 2 to 4, it goes up by 2. From 4 to 6, it goes up by 2. 6 to 8 also by 2, and 8 to 10 also increasing by 2. And then from 2 to 5, you see how they're all the same. They're increasing by the same value. That's what you want, okay? So now you can ignore this column. You don't need this anymore, okay? So you know that the ratio is between 2T and P is the same ratio. Now you look at what you have to add and subtract to go from one column to the other, okay? So after this, okay, compare the new columns with the right and the left, okay? So 2, and this is 3. So 2 plus or minus what gives you 3? So you know that 2 plus 1 gives you 3, so plus 1, okay? And then you check the next row and see they're the same. So 4 plus 1 gives you 5, and the answer is also plus 1. And 6, to go to 7, you also have to plus 1. 8 to go to 9, you also have to plus 1. So therefore, hey, whatever this column is, 2T, if you plus 1, to go from here, you plus 1, it will be equal to P. So therefore, that's how you get this equation. The number of the number of toothpicks you need is the number of the triangle times 2 and then plus 1. Okay? I hope that makes sense. You can also rewind it and play it again if you like. Okay? So here are, okay, there's your formula. Okay, here are two examples. Okay, here's the first one, and here's the second one. So right now, if you want, you can pause this lesson right now. Give students a minute to try this one out. Okay, you can rewind it if you like. Look at an example. So I'm going to pause it right now. Okay, so hopefully you had some time to try this question. So again, the first step is this. Okay, number one, look at how fast each column is increasing. Column is increasing. Okay, so from 7 to 10, you plus 3. From 10 to 13, you also add 3, and add 3. And this side's only increasing by 1, 1, 1, and 1. Okay, so what you want to do is, again, you want the two columns to be increasing in the same amount. So number 2 is multiply to increase by the same value. Alright, so again, you look at the left column, it's only increasing by 1, and the right side is increasing by 3. So what I'm going to do is I'm going to multiply this column x, everything by 3, so you get 3x like this. Okay, so 3x. So this one becomes a 3, the 2 becomes a 6, the 3 becomes a 9, 4 becomes a 12, and the 5 becomes a 15. Okay, and you cross this column now, you don't need this anymore. Okay, third step is you have to add or subtract to find equation. Okay, so again, you look at the rows. Okay, so 3 to go to 7. What do you have to add or subtract? And you know that you have to add 4 to go to 7, right? And then you look at the next row, from 6 to 10, you also add 4. And you look at the pattern, they're all the same, they're all increasing by 4. So therefore, to go from 3x to y, you just have to add 4. Okay, so your equation would then be 3x plus 4 is equal to y, and that would be your equation. Okay, so this was easy. Let's try the second one. Okay, and again, if you want to pause it right now, so you can try it on your own first, it's up to you. Okay, so I'm just going to continue. So from 3 to 5, you have to add 2. 5 to 7, you also add 2, and also add 2. Okay, so these are all increasing by 2. And if you look at the x, they're all increasing by 3. Okay, unlike the previous ones, this is also increasing faster. So what you want to do now is, okay, so the y column is increasing by 2, and the x column is increasing by 3. And you want them to be increasing by the same value. So what I'm going to do then is I'm going to multiply the y column by 3. Okay, so then you get a column here, 3y. Every number in the y column is going to be multiplied by 3. So 3 times 3 is 9, 5 times 3 is 15, this is 21, this is 27, and this is 33. Okay, and then everything in the x column, I'm going to multiply by 2. Okay, and the reason why it's 2 is because you look at the other side, it's all increasing by 2, right? So this will become 6, so 3 times 2 is 6, 12, 18, 24, and 30. And again, in case you're wondering why we're doing this, is because now you compare the rows. They're all increasing by 6 on the right side now. And then you look over here on the left, they're also all increasing by 6. That's what you want to do. Okay, you want them to be increasing by the same value. So therefore, you just want to look at this column 2x and this column 3y. You don't care about this part anymore. Okay, so look at the numbers. 6 all the way to 9. What do you have to increase by? That's just 3. From 12 all the way to 15, you also need to plus 3. 18 to 21, you also add 3, and it works for every single other row. So therefore, from 2x to 3y, you also have to increase by 3. So 2x, which is the left column, plus 3 is equal to 3y. And that will be your formula. Hope this all makes sense. Okay, we're just going to continue on. And then here is one of the last examples. Okay, so this one here is what happens when you have an equation. Can you solve for other values by plugging in numbers? Okay, so here's this example. Okay, hope you remember this. Here's the formula. Okay, so number of toothpicks is equal to the number of triangles times 2 plus 1. And the question is, what if you have 87 triangles? Okay, how many toothpicks will you need? So all you gotta do is, not 30. Okay, 87 triangles. So I'm gonna change this now. Okay, if you have 87 triangles, just go 2 times 87 plus 1, and that will be number of toothpicks. Okay, so 87 plus 87 is 14, 174. So this will be 174 plus 1, and that will be 175. Okay, so the purpose of having a formula is it makes it easier for you to count without having to actually count each scenario. You can just plug the number into the equation and you're pretty much done. Okay, so for example, if I wanted instead not 87 triangles, let's say I want 100 triangles. Okay, how many toothpicks would I need? So you go P is equal to 2 times 100, so T is 100 triangles, and then plus 1. So therefore you need 201 toothpicks. Okay, so having the formula will make things a lot easier. So let's go back to this one here. Is suppose you have 300 tiles to form a walkway around the garden. So what's the size of the largest garden that you can make? So right now instead you have 300 tiles. And so you want to know what size you can work with. Okay, so again, here's the formula. Okay, so 300 tiles. So that means that T is the number of tiles. This T would then be 300. So you plug that in. So 300 equals 2 times the size plus 6. So I hope you remember how to do this from grade 8, depending who taught you. So if you're looking for S, first step is you get a minus 6 on both sides. Okay, so minus 6. And so 300 minus 6 is 294. Let's equal to S. And so 2 times the size is equal to 294. So what I'm going to do now is I'm going to divide both sides by 2. Okay, so that means that S is equal to 147. So the size of your garden is 147. Alright. Anyways, this is it. We are done. There's still one more slide, but you can go online and look at the last slide on your own. Okay, that's it. Hope you have a good day.